What if we unleashed Earth's water onto Venus? Could a scorched, acidic wasteland be transformed into a blue planet like our own? Would oceans tame the planet's chaos or boil instantly under its brutal sky? Could we create a second Earth? Or would Venus fight back with fire, pressure, and poison? Drop your theories in the comments below and stick around to see if you were right. Oceans are poured into its valleys, its craters, its vast basalt plains. In theory, we now have a planet that looks blue from space. This isn't just science fiction. It's a question rooted in real science and extreme imagination. Venus has always been Earth's twin in size, mass, and gravity. Its thick, toxic atmosphere is made mostly of carbon dioxide, with clouds of sulfuric acid. And the surface pressure? Over 90 times greater than Earth's, like being nearly 1 kilometer under the ocean. But while Earth became paradise, Venus became hell. So what happens if we try to rewrite its fate with water? What if we engineered Venus, first cooling it before the flood? Temperatures drop. Volcanic activity settles. The atmosphere starts to thin out. For the first time in billions of years, liquid water exists on Venus. Before we dive in, what's your gut instinct? Would flooding Venus cool it down, or just make things worse? Let's imagine the impossible. Using advanced technology or a future mega-civilization, we somehow move enough water to Venus to cover its entire surface. The added water vapor, a powerful greenhouse gas, would trap even more heat. Venus would get even hotter. But immediately, the reality hits. Venus is not ready for water. Earth is protected by its magnetic shield. Venus is naked. So we'd have to build one, possibly using massive orbiting electromagnets. At 90 bars, Venus's atmosphere would crush a human instantly. The oxygen might help build a breathable atmosphere. The carbon could be stored or ejected into space. Even with oceans on the surface, this dense carbon dioxide layer needs to be reduced massively. The planet's surface temperature is a bone-melting 465 degrees Celsius, hot enough to melt lead. So what happens when we try to add water? First, the oceans don't settle, they boil. Even in the absence of sunlight, Venus's own internal heat and atmospheric pressure cause water to vaporize almost instantly. These boiling oceans would pump incredible amounts of steam into the already superheated sky. That leads to a runaway greenhouse effect. So instead of creating life, the water fuels a planetary pressure cooker. But let's take it further. Let's say we used solar shades to block sunlight, or deployed space mirrors to reflect radiation. We cool the planet slowly over centuries. Now we flood it. This time, the water doesn't instantly vaporize. It begins to pool in lowlands and spread across the surface. But we're still far from habitable. The next problem is atmospheric pressure. One idea: terraformers could use massive chemical plants to break down CO into carbon and oxygen. But this would take thousands of years, massive infrastructure, and robotic labor on a scale we've never seen. Meanwhile, Venus lacks a magnetic field. That means any atmosphere we build is at risk. Solar winds could strip it away. Still, even with all this work, one thing stands out. Venus is resiliently hostile. Every solution creates new problems. Every step forward risks disaster. And we haven't even asked the real question yet. What kind of world are we creating? Is it really Earth 2.0 or something else entirely? Let's say we beat the odds. The oceans don't boil. The atmosphere is partially tamed. Venus now glows blue beneath a hazy sky. Would that make it habitable? Not quite yet. Because while Venus might look Earth-like, it's still a very alien world. The air is still filled with toxic gases. The pressure may have dropped, but it's still lethal to humans without suits. Think massive floating cities in the upper atmosphere, where conditions are closer to Earth's. Eventually, we might build dome-covered surface colonies that recycle air and water while shielding inhabitants from solar radiation. And the temperature, while lower, would likely sit in the range of 50 to 100 degrees Celsius, like living in a sauna. forever. Venus is unstable. With no plate tectonics and a history of global resurfacing events, it could erupt catastrophically again. A single volcanic upheaval could send centuries of progress back to zero. Gravity is close to Earth's, yes, but surface conditions remain harsh. To survive here, humans would need enclosed, pressurized habitats at least in the early stages. Venus might teach us how to engineer atmospheres. It might show us what happens when a planet collapses under its own chemistry. That's a much harder sell. But it may never become a second Earth, not truly. With less atmospheric pressure and temperature, it's a blank slate. And while Mars doesn't have water to begin with, adding it wouldn't trigger runaway effects like on Venus. Tell us your choice in the comments, and don't forget to subscribe for more mind-bending science every week. Terraforming Mars might be easier, cheaper, and more forgiving. Life could exist, but not freely, not like on Earth. Algae could grow in shallow waters. Simple organisms could begin forming aquatic food chains. In some valleys, primitive lakes might start showing early signs of ecological stability. That means one side of the planet bakes in sunlight for months at a time, while the other side sits in darkness. This uneven heating would create monstrous storms and wind currents, challenging even the most resilient engineering. We could even see synthetic biology used to design new life forms that can survive Venus' chemical makeup. Over centuries, if the atmosphere is managed and oxygen is added, certain extremophile plants could be introduced. Still, the threat of catastrophe would never be far. And what about the skies? Venus has an incredibly slow rotation. One day on Venus lasts longer than its year. Now compare this to Mars. Yes, it's colder and drier, but it's already somewhat stable. So here's the real question. Is terraforming Venus worth it at all? The cost, time, and risk might outweigh the reward. Instead, Venus could become a scientific outpost, a testing ground, a partially livable station for observation and atmospheric manipulation. But a permanent home? And yet, the dream lives on. Because if we could tame Venus, if we could walk on its surface and see oceans where once there was fire, it would mark the greatest engineering achievement in human history. It would prove that even the most hostile planet in the solar system could be reborn, not just to survive, but to live. So, what do you think? Should humanity focus on fixing Earth or transforming Venus?